In the last class, we all already discussed this topics, right? Element, what is element, what is compound, etc. So, what is element? Element is made up of similar kinds of atoms, right? And the smallest part of it is the atom, right? Yeah. Is it okay? Very fine. Look, responsibility. Fine. It was already taught, right? So, I remind all that there are three types of elements: metal, non-metal, and metal ions. Fine. We have talked about this. But and then we told that these pure elements or pure compounds. Compound is what? Compound is nothing but a matter which is made up of more than one either similar or more than one dissimilar atom. But they should be combined in a definite proportion. You cannot have a compound by mixing any amount of more than one substance. Okay. So when we say this, these are the two pure forms of matter. What are the impure form of matter? We also talked about that, and that's nothing but mixture. You can do any pure form or more than two forms and mix them simply physically. So that becomes a mixture. So mixture is basically a form of matter which contains more than one type of atoms mixed in random ratio. So a mixture doesn't when you talk about a compound, the compound doesn't reflect the property of the components. Whereas in a mixture, it is basically the reflection of the components and the percentage of different components present in it. So mixture and compounds are thoroughly different, although they both contain dissimilar or more than one pure element, more than one uh, pure matter. Okay, but the thing is, mixture can be separated physically, but compound can only be separated either electrically, chemically, or you can be nuclear transmutation. Fine, we talk about this. So we talked about also talked about that there are different types of mixture. One is suspension, one is colloid, and another is solution, homogeneous mixture. Heterogeneous mixture, homogeneous mixture. Heterogeneous mixture again. Two forms, colloids and suspensions. Okay, we talked all these things. Now we will be talking about solutions. Yes, in the last class I gave a hint. Now we will be talking in more details. Uh, so basically, solution is a homogeneous mixture. We have already told it, and solution consists of there are many phases. Okay, so the amount of substance which is present in the maximum amount, but maximum quantity, we call it a solvent. All other components are solids. Fantastic. We also just simply gave an indication that alloy is a special type of solid solution where two solids are mixed and one of the component has to be harmonic. Okay, fine. So we will not go into this, but we have already talked about suspension, colloidal suspension. We have told different types of suspension we have talked about. Now we talk about concentration. So what is the concentration? How you define concentration of solute?
The mass of solute. Solute.
In a given amount of solute. So in the next slide now. Next please. Yeah. Next. Sorry. So, okay, before I jump into the concepts of solution and how we will measure it, what are the relation of different types of ways of defining solution and concentration. Let me just introduce you to certain other things which I missed in the last class. So basically, before this atomic structure is being taught by somebody else. Have you already taught? Yeah, maybe we'll be taught. Actually, it's not in my domain. So before the atomic structure was known, before scientists or chemists could know what is inside an atom and how actually the reactions take place. But semi-empirically, by qualitative and quantitative study of many large number of reactions, they concluded certain rules. We must understand that these laws or these rules are developed by studying empirically. There is no there was no fundamental basis of these rules. But it is whenever people see a large number of events occurring, you can get to decide what governs them, right? So that's how these rules came. So one of them is definitely law of preservation of mass. In no chemical reaction there can be any change of mass. Okay? And obvious. If you have to convert mass to energy, you need some other thing, right? So, law of preservation of mass states that in a chemical reaction there are also laws of mass. That is, sum of the mass of the reactant is equal to sum of the mass of the product plus sum of the unreacted reactant reactions. So you start with some compound, start with some reagent, they react and partly convert to a compound. Now when you measure the weight, initially your weight was something, and finally also if you just add up the weights of the product form and the unreacted components, you'll get the same. So this is the law of preservation of mass. Second is the law of constant proportion. What does it mean?
The ratio of the weight of the elements in a compound are always constant.
Very well said. So, a definition of a compound. How do you define? How do you separate? How do you say that one matter is a mixture of two element and matter is a compound? I mean, how? What's the basis? Suppose you have two metals mixed in the form of an alloy, and there is an intermetallic compound being formed. So how do you differentiate it? First of all, the property of the compound will be way different than the components. Okay? I mean, I give you a simple example. Hydrogen is combustion, and oxygen helps in combustion, and water does the opposite thing. Okay? मतलब extinguisher. Okay? Water is formed by hydrogen and oxygen, right? So this is one thing. Another thing is you cannot have a variation in the composition of a compound. So a compound is made up of elements, specific elements. एक बार वाटर हाइड्रोजन ऑक्सीजन से मिला बना, दूसरी बार क्लोरीन और सल्फर से बन नहीं सकते, right? So the law of constant definite proportion says that any compound is made up of fixed elements combined together in a definite ratio. By weight. Okay. For example, water collected from anywhere, take it from your water bottle or from the tap or anywhere or from the pond, they contain 16 parts by weight of oxygen and 2 parts by weight of hydrogen. Clear? Kya is low. Huh? Then there is a law of multiple proportion. Any idea? Multiple proportion क्या बोलता है?
So that two elements can combine in multiple ratios to form different compounds.
What to say? Yeah, it's correct. But let me elaborate it on your thoughts. So मान लीजिए दो एलिमेंट combined to form more than one compound. If two elements combine to form more than two compounds, I give you an example. Example is given here. So hydrogen reacts with water, oxygen to give water. So one H2 plus half O2 gives H2. Reaction is given. Similarly, hydrogen can react with oxygen to give hydrogen peroxide. So H2 plus O2 gives H2O2. Now, the weight of one element which combines with the fixed weight of the other element to form these two different compounds. In the two compounds, we have a simple whole number ratio. इसका मतलब क्या है? Here also you see in water 16 parts of oxygen react with 2 parts of hydrogen by weight. In H2O2, 32 parts by weight of oxygen reacts with 2 parts of by weight of hydrogen. So in both the cases, 2 parts by weight of hydrogen reacts with either 16 parts by weight of oxygen or 32 parts by weight of oxygen. So 16 and 32, they are having a simple whole number ratio of 1:1. So that's the mool of this. ratio of the masses of oxygen in these two compounds which react with a fixed mass. What is the fixed mass? 2 mass of hydrogen in these two compounds. We have a simple ratio of 1:2. So law of multiple proportion समझ में आया? So okay. ये होता है क्या? You had a wonderful lunch, I think now. Just now होता है. Don't get that. Don't. मुझे भी होता है. Okay. Law of multiple proportion. Now comes law of reciprocal proportion. This is basically an extension of what we will be learning in next 2 slides. Basically law of equivalence. Okay. So what happens here? You see, suppose there are 3 elements A, B, and C. Now A and B react to make a compound, and C and B react to make compound. So common element is B. Okay. Now, what law of reciprocal proportion says that the mass of one element which reacts to the fixed mass of another element to give a compound, okay, we have a simple whole number ratio of the mass when they react with each other. इसका मतलब simplified मतलब क्या होता है? Suppose I give this best explain. So the masses of 2 elements that separately react with a fixed mass of third element is either the same or simple multiple of their masses when they react with each other to form a compound. So इसका best explain with the help of an example. मान लो H2S है. H2S में क्या एलिमेंट है? A hydrogen है as sulfur. So 2 parts by weight of hydrogen react with 32 parts by weight of sulfur. SO2 में 32 parts by weight of sulfur reacts with 32 parts by weight of oxygen. Now when oxygen and hydrogen they react together, that ratio of their masses will be either the same or a simple multiple of this. I mean, see in H2S, 32 parts by weight of sulfur reacts with 2 parts of weight by hydrogen, and in SO2, 32 parts by weight of sulfur reacts with 32 parts by weight of oxygen. So what is the ratio? 2:32 or 1:60. So that is the ratio of the mass of water. क्या हो गया? So it is here 1:16, and there you have 2:16. So it is ratio is 1:2. So when they combine, so in water what happens? You got it, na? So in SO2, 32 parts by weight of sulfur reacts with 32 parts by weight of oxygen. In H2S, 32 parts by weight of sulfur reacts with 32 parts by weight of oxygen. So the ratio of mass of oxygen in this SO2 and ratio to the mass of hydrogen in H2S is 2:32, or basically 1:60. Right? In water, what is the 2:60? Right? So it is simple multiple 2 times. What is? So ratio is. So this is what law of reciprocal proportion states. That when hydrogen and oxygen they will form a compound themselves, the ratio of masses will be either the same or a simple multiple of what they form into different compounds or other compounds. Fine. Next is the law of gaseous volume. Law of gaseous volume says that in a reaction, the volume of the reactant gases is the same as the volume of the product gases, assuming that 100% conversion is there. Otherwise, plus, yeah. So, but the measurement has to be done at the same temperature and pressure. So basically, what it says, gases combine and are produced in a chemical reaction in simple ratio by volume measured at the same temperature and pressure. So reactant volume at the same pressure at temperature, we have a simple ratio to the product. So basically, what happens actually, I have told in the last class also that reaction takes place in equivalent amounts. And in another year, we told that equivalent weight, we have a simple full number ratio is a simple submultiple of molar mass. And again, 1 mole of all gas at same pressure, we have the same volume. So if you combine all these three, you will get to the understanding of this gaseous volume, law of gaseous volume. Fine. Finally, we have Avogadro's law. I will come and explain all this equivalent weight and all this in the next class. Slides. Avogadro's law what it states? Equal volumes of all gases at same pressure and temperature contain equal number of molecules. Yeah. So at STP, what is STP? What is value? 1 bar and 0 degrees centigrade. So at that condition, Avogadro number, that is 6.022 into 10 to the power 23, number of molecules of all gases, all ideal gases rather, occupy 22.4 liters. So this is Avogadro's law. Gaseous volume you understood now. Why? Because I told you that reaction takes place in equivalent amount. I will take this mathematically reiterate it in the next slide. So so suppose X equivalent of reactant will produce X equivalent of the product. Now equivalent weight has a simple relation with molar mass. Okay, and we have seen from the Avogadro's law that molar volume of all gases at same temperature and pressure is the same. So if you combine three, you will get this law of gaseous volumes. Okay, next slide. समझ में आ रहा है? Yes. Because in the feedback somebody told that many things were not understood, but I think the last class was simply elementary. I want to go into the deep in this class. The GSO is meant for having a glimpse of some advanced features, right? Not the same thing. Fine. So we have been talking about element, compound, and mixture, and all these things. And then we come to the concentration. Concentration is the amount of solute present in a fixed volume or fixed amount of solute. So that's how is concentration all about. Before we learn about concentration, we just want to learn a few terms which you might have already learned in other chapters. Atomic mass of an element. I told you in the last class also, it defines how heavy an element of that, how heavy an atom of that element is as compared to 1/12 part of carbon 12 isotope, right? So that's how we find our atomic mass unit, which is the reference of measuring atomic mass of any element. So how is that? Atomic mass unit is the mass of 1/12 part of carbon 12 isotope. So carbon 12 isotope ka mass is assumed to be 12. Okay, so 1/12 part is definitely the unit of atomic mass. So that's how the atomic mass is derived. And what is its value? Its value is 1.66 into 10 to the power 24 gram. Atomic mass expressed in grams. कोई भी element का atomic mass expressed in grams gives you gram atomic mass. What is the significance of that?
The mass of 1 mole of.
Perfect. So it is basically the mass of 1 mole of that element. That is the Avogadro number of particles. The mass goes. Next. We also just quickly told that since elements they exist in nature in different isotopic forms. So the atomic mass of an element is basically an average of all the atomic masses of all the elements. So how is it found out? The average atomic mass is the average of atomic masses of all the isotopes, and it is found by summing up the percentage of atoms into the atomic mass of individual isotope and then multiply it with, divide it by 100. Okay. I have given an example, that example of chlorine almost. So we have understood what is atomic mass and average atomic mass, right? Average atomic mass comes from the average of all the atoms. That's it. Molecular mass is again, we told our reference is 1/12 part of carbon 12 isotope, and we want to compare how heavy a molecule is with respect to our reference. That is atomic mass unit. Atomic mass unit. So molecule को भी atomic mass unit से ही करते हैं. Fine. So molecular mass of a compound, it defines how many times the mass of the compound is higher than that of 1/12 part of the carbon 12 isotope. It is basically the sum of atomic mass of all the constituent atoms present in the compound. And formula mass we have also told, somebody raised a question that we discussed that some of the compounds actually cannot be expressed in terms of discrete molecules. They are given formula weight instead of molecular weight. Now comes one of the most important concepts, and that is called mole concept. So mole is nothing but an amount. Just a dozen mole, dozen. What does dozen mean? 12. Anything which contains a dozen of eggs, a dozen of hoops, a dozen of pencils. So dozen is basically a unit number. Similarly, mole is any quantity that contains Avogadro number of entities. So entities can be molecules, atoms, or say particles like protons, electrons. You see that, sir? So how do you find the number of moles in a molecule? Suppose you are given some weight. Similarly, you want to find the number of atoms. You are given. You want to find the number of moles of atoms. You have given 20 grams. You are trying. If it is a gas, what do? We use that relation that at ASTP, volume of 1 mole of gas is 20.4 liters. So you know the volume of the gas, reduce it to STP, you measure the volume of the gas, and then divide by 20.4 and it gives the number of moles. Elementary particles like electron, proton, neutron, etc. So how do you know it?
The number of particles.
Number of particles divided by Avogadro number. So these are the ways you can find 1 mole of thing. Now, how to find the mass of one particle? I told you that molecular mass, when expressed in grams, actually represents Avogadro number of mass of Avogadro number of particles. So, if you divide molar mass by Avogadro number, you will get the particle mass of a individual particle. So, that is what was required. I skipped it. I put it here. Next. Now comes concentration. So there are different ways of expressing concentration. Okay. One of them is mole fraction. The name itself you will follow is self-explanatory. Mole fraction. But if you have A, B, C, 3 different types of pure matter and they are in a mixture, you want to find what is the mole fraction of A. So basically number of moles of A divided by number of moles of A plus number of moles of B plus number of moles of C. So total number of moles A, B, C का कितना है? उसके ऊपर number of moles of A. So that gives you the mole fraction of A. Similarly, there will be the mole fraction of B. It is the number of moles of B divided by total number of moles present in the solution. Number of moles of C, it is the mole fraction of C and like that. Now, if we have binary mixture, that means there are only two components. And one of the mole fraction of one of the component is XA and mole fraction of another component is XB. And if we add XA plus XB, what is the value? Why one?
Because it's a fraction.
Fantastic. So if it's a binary mixture, always you can find out the if one of the mole fraction is given, you can always find out the mole fraction of the other component, right? Fantastic. Then we come to the second very important way of expressing concentration, that is ppm. You will see when we say very small amount of things, we call this a ppm. Now there is a fashion of telling ppp, ppt, parts per million, parts per billion, parts per trillion. So what does it mean? Parts per million is basically the way of expressing concentration of solute present in a solvent, present in 10 to the power 6 parts of the solution. So if you have, suppose, some mass of the solution, and you have divided by you have mass of the solution. So divide mass of the solution into mass of the solution by mass of the solution into 10 to the power 6. That gives you ppm. Unitary method से मतलब क्या है? अगर मेरा x gram of solute is present in my y gram of solution, then 10 to the power 6, 1 million parts of my solution is the solution. So usually this mode of expression of concentration is given for very dilute solutions, where the solute is very less. You can understand that?
Yes.
So suppose you have 1 milligram of the solute, okay, and you have 1 kg of the solution. So then we will say 1. So 1 ppm is defined as 1 milligram of solute present in 1 kilogram of the solution or 1 liter of the solution. Both are universally used, especially for water. Okay. So you are getting it now. Now ppm is understood. So ppm is defined as the parts of the solute present in 1 million parts of the solution. Similarly, pp is
Parts per billion.
million, ppt is in 10 to the power 9 in 10 to the power. Very good. Next comes percentage. I mean, there are 3 different types of percentage notation. One can be weight by weight, one can be weight by volume, one can be volume by volume. Weight of the solute divided by weight of the solvent, solution, into 100. It is called mass by mass percentage. Next is volume of the solution, volume of the solute divided by volume of the solution into 100. And third is mass of the solute divided by volume of the solution into 100. That is 1 gram of the solute present in 100. 100. Say 1 milligram of the solute present in 100 ml of the solution. That will also be 1%. Now, tell me one thing. How many percent is 1 ppm? How many ppm is 1%? Anything you can do. Fantastic. So 10,000 ppm makes 1 ppm, 1%. Okay. Okay. Now there are 2 more. Actually, there are 3 more ways of expressing concentration. One is called molarity. So how is molarity defined? Can anybody say? Liter of the solution. Fantastic. So it is defined as the number of moles of the solute, moles, not grams, moles of the solute present in 1 liter of the solution. Solute in solution. So that's how. So molarity can be actually defined as, suppose you have 2 grams of solute, you divide by, get 2 suffixes always for solid, 1 is for solvent. That's how conventional use. So 2 grams of solute you have to divide with molar mass of the solute. So it gives you the number of moles of solute, and that is present in V liters, suppose in ml. So V by 1000 makes it liter. So in 1 liter, how many moles of solute is present? And that is molarity. Okay. Next. This is a cousin brother, molality. Here the definition is little different.
1 kg of solvent.
1 kg of the solvent. So molarity is defined as the number of moles of solute present in 1 kg of the solvent. Here also you see M2 is uh, yeah. So I don't know why I have used W1. It should be W. So moles W by M2 gives you the moles of solute divided by, you have to find the weight of solvent. Okay. So how do you find the weight of solvent? You need one more term, which is called density. Okay. So you multiply by density, you get the total mass of the solution. Now you might subtract the mass of the solute. How do you get it? You know the weight of the solute given, either or the number of moles given. So molarity gives the number of moles, right? So you know molarity into molar mass. That gives you the mass of the solute. Am I clear? Molarity gives you the number of moles of the solute present in 1000 grams of the solvent, okay, or 1 kilo of the solvent. Now, N stands for number of moles in 1 kilo of the solvent. How to find out what is the if you know the volume of the solution, you multiply with the density, it gives you the mass of the solution. So the total mass of the solution is known to you. And from there you have to subtract the mass of the solute. The mass of the solute is subtracted by molarity, that's mass, number of moles into molar mass. So that's what we have done it in this bracket. Okay. So that's how you can get a relation between molarity and molarity. I will not go into the details, some sketch work has been given in the slide, you can see. So the relation becomes molarity equal to 1000 into molarity divided by 1000 P minus molarity into M2. M2, two suffix is always a solute. Got it? Okay, so that is the molar mass of the solute. Fine. All things are related here. Similarly, if you do little bit generally with this equation, you can get out that molarity is nothing but M into D divided by 1 plus molarity into molar mass of the solute divided by 1000. So this relation between molarity and molarity can be found. Similarly, you can find out relation between molarity and mole fraction. Okay. So mole fraction of solute is given by this is the mass of the moles of the solute divided by moles of the solute plus 1000 grams divided by molar mass of the solvent. Getting my here? How? See, M denotes your molarity, right? So molarity is nothing but the number of moles of solute. So it is there, and in the denominator you have moles of the solute. So M is there, and this is the mole of the solvent. Why? Because you have 1000 grams of the solvent divided by molar mass of the solvent M1. So that gives you the I2, and then you do a little bit of general, you can arrive at this equation. Okay, so I2 equal to M into M1 divided by M into M1 plus 1000. Notations are next. Similarly, you can arrive at the reciprocal equation also. That molarity is equal to 1000 into I2 divided by I1 into M1. That's I2 and I1 are the mole fraction of solute and solvent. Am I clear? Right. Now, relation between molarity and mole fraction. Say again, similar type of mole fraction and I2 equal to molarity divided by. This is the weight of the solvent. Last slide we have done it, 1000 minus M2 into M. So weight of the solvent divided by molar mass of the solvent gives you mole fraction. And plus you have M2, that's the mole fraction of the solvent. So this is the total number of moles. And on top you have molarity. Molarity is nothing but the number of moles in 1 liter, right? So that gives you the relation. These relations are very important in solving advanced problems which you will be facing maybe after 12 or so. But you need to get acquainted with these terms and relations. Okay? So that. There is one more way of representing the concentration, and that's called normality. But before coming to that, we need to understand the concept called equivalent weight. Can somebody tell me what is equivalent weight of an element? And what is the equivalent weight of oxygen? What is the equivalent weight? What?
Oxygen to eat. The equivalent weight is we have said 16 grams of oxygen, 32 grams of sulfur, or 2 grams of hydrogen.
Equivalent weight of an element is defined as the weight of the element that combines with लिखा हुआ है देखिए तो बता 1 gram of hydrogen or 8 gram of oxygen or 35 gram of chlorine. So basically 1 gram of hydrogen means 1 atom of hydrogen. 1 atom of hydrogen के साथ जितना atom of that element है उसका mass जो है उसको equivalent weight बोला जाता है और 8 grams of क्या हो गया सर एन हो गया एन फैक्टर होता है ना एक तो एन फैक्टर होता है हां एक वही एन फैक्टर ही बोल रहा हूं नीचे तो 8 grams of oxygen बोले तो oxygen is standard each oxygen atom combines with 2 monovalent element क्लोरीन हाइड्रोजन के साथ 2 हाइड्रोजन के साथ कंबाइन करता है क्लोरीन इज मोनोवैलेंट और ऑक्सीजन इज डाइवैलेंट इसलिए ऑक्सीजन का एटॉमिक मास के हाफ होता है so basically it is the mass which is combining with one hydrogen atom, half oxygen atom, or one chlorine atom. Clear? So weight of an element is defined as the weight of the element that combines with 1 gram of hydrogen, 8 grams of oxygen, and 35 grams, 35.5 grams of chlorine. So equivalent weight is basically atomic weight divided by valency. What is valency?
In fact,
नीचे ऊपर नहीं नीचे देखो तो वैलेंसी क्या है combining capacity of an element so it is the valency is nothing but the combining capacity of an element तो जैसे मैंने बोला एक सिंपलेस्ट एग्जांपल वाटर एक्चुअली मुझे बहुत प्यास लगा है इसलिए मैं वाटर पी नहीं पा रहा हूं तो I know that is water. तो इसका बैलेंस क्या है? इसका बैलेंस क्या है?
hydrogen by oxygen.
Fantastic. So in a compound, it is reflected as the reciprocal. वो exchange हो जाता है ना? A into O3.
AL3 or O5. AL3 plus O minus.
बराबर ना सो हाउ डू यू नो क्योंकि एक ऑक्सीजन 2 हाइड्रोजन के साथ कंबाइन करता है जिसका 2 है तो 3 का ये है 6 डिवाइडेड बाय एलिमेंट का 2 एलिमेंट 2 एटम्स combined so it is combined properties so if you have a binary compound your valency gets exchanged it's a combining process next case we have a term called N factor. So equivalent weight is given by atomic weight or molecular weight divided by N factor. Now how you define N factor? N factor can be defined in a lot many more number of ways. Suppose you have an acid. So it's the acidity of it is the basicity of an acid. मतलब कितना replaceable hydrogen है. So H2SO4 का N factor क्या है? 2. HCl का 1 देखो सबसे इजीएस्ट एग्जांपल लेके टीचर कर देता है ना अब बाकी आगे चल के कॉम्प्लेक्स प्रॉब्लम्स सॉल्व करना पड़ता है सिमिलरली एसिडिटी ऑफ ए बेस number of weight or in how many H class it can take depends there are different ways of defining acid and base and when you have a salt you have to take the number of cations or anions into their charge. Salt is a neutral, ना? So एक को ले लो, cation को ले लो या anion को ले लो. सोडियम सल्फेट, सोडियम का चार्ज कितना है? 1. कितना है 2 into 1. या सल्फेट को ले लो, सल्फेट का अमाउंट कितना है 1. उसका चार्ज क्या है 2. Sorry. No problem. I'll be back on the Can I please speak? Okay, fine. So you have acidity of the base, basicity of an acid, and number of cations or anions. Now cations लिखा है ऐसे मतलब ये cations और anions into multiplied by charge in this one. Okay. So number of equivalents क्या होता है? Number of equivalents like weight divided by equivalent weight. Weight, your weight given divided by equivalent weight gives you number of equivalents. So why is it so important that number of equivalents? Because in a reaction, where the reactants are in stoichiometric ratio, I mean, there is no excess of any reagent. In that case, all the reactants and products exist in equal number of equivalents. मतलब समझ में है? क्या मतलब समझ में है?
Sir, equivalents are the weight of an element relative to one in the
मैंने अभी जो बोला उसका मतलब in a reaction where there is no limiting reagent or excess reagent, the number of reactants and products all are either equivalent in terms of the equivalence. So reactants react in terms of equivalence, products are also formed in terms of equivalence. मतलब again water.
सर को बोलते हैं
What this statement makes out is आप बातें कर रहे हो, you will miss subtle things, and ये 2 साल बाद जाके आपको इफेक्ट करेगा. Why you are dared to do it because you are going to some cooking classes or some tuitions or something. You think that things will be required, but sometimes you get to miss there also. By chance you can recover it here. लेकिन ये जितना भी मिस कर रहे हो उधर भी मिस कर रहे हो, just your probability is decreasing. I give you an example. Reduction आपका हो गया, हैं? Come on. Tell me what is the oxidation state of carbon and nitrogen in cyanide and acid ions? Anybody who can come and tell it, I can just get him outside and he can play. My responsibility, talking to the person. Oxidation state of carbon and nitrogen in this group. So who are you?
The C plus 2 and minus 6. From element C plus 2 and minus 3.
C is plus 2
and minus 3.
Okay.
Yeah.
And what about this?
Sir,
And can you explain how you get it? It shouldn't be something from your memory. You have to get it.
Sir, C has variable valency, whereas N mostly has minus 3. So,
Do it there and reduce it. How you get it? मेरे को इतना रेस्ट नहीं दे रहा है. Stand up and say what is the basis of this. It can be 2, 3, 4, 5, any number. It doesn't matter. How you are finding it? What is the basis? हो गया ना? I'm very sad to say because I follow this crowd for the last 5 years. I've been teaching in different forms. Hardly two students get to score below 500. 1500 नीचे 4 4 5 बच्चे के नीचे होता है, ऊपर नहीं होता एंड 20 बच्चे से ज्यादा 20 35 बच्चे से ज्यादा 10,000 के नीचे नहीं है. This is the scenario. ठीक है, but I'm talking about your attendance. That's the where the challenge lies, right? लेकिन इस जगह में जाओगे तो ये इस wherever you are getting a chance, somebody is coming and teaching you, anybody. अच्छा सुनो ना, इसमें क्या प्रॉब्लम है? Maybe you are smart, maybe you are knowledgeable, but अगर कुछ चीज मिल जाए जो आपने सीखा नहीं, क्या प्रॉब्लम है? सीख लो. ओवरस्मार्ट करके उसको कोई भी अगर निकल जाओगे वो ये है, लेकिन होता नहीं. दिस इज द स्टैटिस्टिक. क्यों नहीं होता है? अरे यार, नहीं बोल पाया ना. See, this is not taught usually. I don't know. I'm not telling in anywhere. The thing is, we are taught to find out the redox, oxidation state in comparison to something. Say HCl. इसका hydrogen to one couple of chlorine minus like HCl is neutral. Like that. In comparison. But we don't say what is actually oxidation state is. Meaning क्या होता है? Meaning होता है कि suppose here this is the excited ion. If all the bond is basically shared number of electrons that are given completely hypothetically to the more electronegative element, then what is the formal charge on that is basically is the oxidation state. मतलब इसमें एक इलेक्ट्रॉन नाइट्रोजन का था, एक इलेक्ट्रॉन नाइट्रोजन का था, एक कार्बन का था, एक इलेक्ट्रॉन कार्बन का था. मैं सब उठा के नाइट्रोजन को दे दिया और इलेक्ट्रॉन नाइट्रोजन, तो 2 इलेक्ट्रॉन ज्यादा हो गया. एक तो पहले से चार्ज था, so oxidation state becomes 3, and since carbon lost 2 it becomes plus. कहीं देखा है? मैंने बोल रहा हूँ कि हार्ड डिस्क खराब है, हार्ड डिस्क अच्छा है, कहीं ने देखा होगा, इसलिए you put it, but you don't know what you approach the answer. Correct. So basically, in oxidation state, you have to give the entire lot of electrons to the more electron. So that's how the formal charge that denotes your. Here you cannot compare because neither nitrogen is standard, neither oxygen is standard, carbon is standard. इसका भी variable balance होता है, इसका भी variable. करोगे तो क्या? पेरोक्साइड ऑक्साइड है, इसमें सुपर ऑक्साइड में एटलीस्ट ऑक्सीजन का कुछ मालूम. ये तो कर नहीं सकते. Anything can happen. So this is the actual definition of oxidation state. So fundamentally. Okay. So in a reaction, so what is the importance? So what I can say is one equivalent of hydrogen will react with one equivalent of oxygen to produce one equivalent of sulfur, not equivalent. Whenever carbon calcium oxide or carbon dioxide taking the charge of carbon. See, here 2 moles of 1 mole of hydrogen is reacting with just multiply with 2. So it gives you 2 moles of hydrogen and 1 mole of oxygen. That gives you 1 mole of water. So if you are doing it in terms of moles, okay, then you have to know the balanced equation. This equation is anyway very simplest of the things, but when you are handling complex equation, you need to understand the balanced equation. But even if you are not doing the balanced, knowing the balanced equation, if you know the equivalent weight of the elements, you should be able to, without knowing the balance also, you can say how much product will be formed and how much you will be formed. So number thing is defined as number of equivalents of the solute present in 1 liter of the solution. Just similar to molarity. So molarity is nothing but equivalents. Just we had used molar mass in case of molarity. Here it is equivalent. So number of equivalents present in number of moles present in 1 liter is molarity. Number of equivalents present in 1 liter of the solution is called number and is represented by N. So obviously, we can tell you which one is going to be higher, if at all. Molarity or normality?
Normality.
Molarity. Normality छोटा होगा लेकिन कहाँ से करेंगे? You missed it in numerator and denominator. That's it. So n times molar, n factor into molar normal solution is molar solution. N can be 1 also. HCl, n is 1.
Sir.
So molarity and normality are same.
Sir, can I explain once more what is n factor?
N factor is an arbitrary factor which is defined as acidity of a base, basicity of an acid, valency or cationic charge into number of cations or anionic charge into number of anions. Got it? So, इसमें क्या गड़बड़ कर दिया? इसमें simple balance में गड़बड़ कर दिया. So here, what happens? Two gram equivalents of hydrogen is reacting with 2 gram equivalents of oxygen. मैंने क्या बोला था ऑक्सीजन का? 8 grams ना. So अरे यार ये कहाँ से आ गया? ये half होगा. So H2 plus half O2 gives you H2O, right? So when you are dealing with moles of reaction, you have to know the balanced equation. It's a very simple balanced equation, but that can be very complex balanced equation. It may take time. So even without understanding, even without having a prior knowledge of balanced equation, if you know that in a reaction, reactants are always reacting in terms of the equivalent weight or number of equivalents. See here, these 2 equivalent of hydrogen, right? Huh? What? It is 1 equivalent of oxygen and giving 1 equivalent of water. That's it. So similarly, if you take a base or an acid solution, an acid solution having a normality of N. So what does it mean? Number of equivalents present in 1 liter. So you have given V1 is the volume and N1 is the normality of the acid. So N1 into V. N1 is the number of moles per liter and V1 is the V liter. So N1 into V1 is the number of equivalents of the acid present, right? Now you have to neutralize this acid. So how much equivalent of base is required? N1 into V1. Now suppose the strength of your base is N2. How much volume you will require? You will buy N2. If you require V volume, then N2 into V2 is the number of gram equivalents of base. by condition of my law of equivalence, it is A1 B1 has to be equal to into B. Okay, completely neutralized category. And this method of neutralizing acid with the base is called titration. Usually use an indicator which shows that endpoint is reached or not. Got it? Now I will just introduce a very effective concept which is called MEQ or uh, millimolar or milli equivalent. Usually your concentration is given in normality or molarity, but the volume solution is given in milliliter. So MEQ concept or millimolar concept that helps a lot. What you are doing is basically 1000 part. You are doing millimole or milli equivalent representing 1 milliliter. So 1 milliliter of the solution, if it is 1 normal, will produce 1 MEQ of the solution. Similarly, 1 molar solvent, if it is present in 1 ml, you will get 1 millimolar solution. So milli concept is being introduced because we handle solutions in terms of ml and not in liters. Okay, please. Vapor density. What are the auto and derived relation? What is the meaning of what is the definition?
Relative density of gas with respect to heavy.
So it defines how dense or how heavy a gas is with respect to that of hydrogen. It is the ratio of the density of the gas to that of the hydrogen at same temperature and pressure. Okay? Because at different temperature and pressure, it will density will vary, right? So it can be shown that the vapor density of any gas is nothing but molar mass divided by 2 molar mass and denotes the molar mass of the gas. Achha. All these things. So we have studied all kinds of concentration, way of expressing concentration, right? Any doubt anywhere? Normality, molarity, molality, percentage, ppm.
That was what I'm not sure what is the spontaneity.
Formula on formula instead of molar weight. I told you that everything cannot be expressed in terms of discrete molecules. So where one formula is there, is formula weight. Okay. Now one kind of stoichiometric problems come when we need to find out what is the molecular formula, what is the empirical formula, and from so how do you do it? Usually some weight percentage are given. In a compound, so and so is present with such a percentage, so and so is present with such percentage. And so how we go about it? So we learned something called mass percentage of element. What is that? It is respect the mass of the element in one mole of the compound into
100 divided by molar.
गलत लिखा हुआ है अरे divided by molar mass इधर लिखा है ठीक है so mass of the element present in one mole divided by molar mass total mass of the one mole into 100 so कितना element है एक मोल में divided by total molar mass and into 100 that gives you the mass of the element empirical formula किसको बोलते हैं empirical formula is defined as the simplest ratio of elements present in a compound. Okay, simplest whole number ratio of elements in a compound. And molecular formula it gives you the actual element and ratio of ratio in a compound.
The empirical formula is the simplest ratio of an atom in a molecule.
Perfect. That's what it is. Simplest whole number ratio of elements.
Yes.
क्या बोला आपने ratio of atom in a
The simplest ratio of an atom in a molecule.
तो गलत लिखा हुआ है atom. Correct. An actual atomic ratio of elements in a compound. The atomic ratio. So empirical formula may be calculated for mass percentage. You know the mass percentage? How do you do the empirical formula? You have to know how many gram atoms of that element is present. So you have to divide it in mass. So that gives you
Empirical formula.
and you get the simple ratio of atoms, right? So that gives you the empirical formula. Again. Okay. So empirical formula may be calculated from the mass percent of our units present. For example, molecular formula, we need the actual molar mass. Acetate, what is the you know what acetate? What is the molecular formula of acetate? Correct. So what is the empirical formula? Those so it is the simplest ratio of hydrogen and carbon. So its empirical formula is C. So you have understood how we can arrive at empirical formula. Empirical formula is the simplest whole number ratio of atoms of elements, not elements of atoms of elements. Similarly, it is actual element atomic ratio of elements can occur. Okay. So empirical formula can be calculated, and from there we can calculate the molecular formula. For that we need molar mass. Empirical formula into some factor should be molecular formula, right? So for that we need the molar mass, and molar mass can be derived from paper density. We determine by 2. There are some other ways also. Log spectrum, I am not written that. Specificity in molar atomic mass is always gives you 6.4. There are some standard relations that we can get. Stoichiometry provides amount of reactants used and products produced. For that we need a balance equation. Itna amount of reactant will produce itna amount of product that is given by stoichiometry. Balance equation, total number of atoms of each element is equal on both left hand side and right hand side. Elements and compounds on the left hand side are called reactants, whereas on the right hand side they are called products. So there should be what balance equation tells you is there should be equal number of reactants. I mean number of elements present in the left hand side of the equation, that is in the reactant, should be the same as number of atoms of the elements which are present in the right hand side. Okay. Now, while we are talking about this balance equation of stoichiometry, there is one more concept which is called limiting reagent. Now, that can be that one of the reagent is in excess. Then the balance equation demands. You are putting some reagent in an excess. So that will not be assumed. Agar you are putting it in balance in the stoichiometric form, that is, जो balance equation में लिखा हुआ है. मान लो, हाँ, एक molecule of hydrogen use किया, half molecule of oxygen use किया, then nothing will be left here. But suppose I put excess of oxygen, then oxygen will be left out. Only it will be used till hydrogen is present. So this is the reagent which is present in less amount and gets exhausted during the reaction is called limiting reagent. Okay, so it's very easy to find out. You can find it from the balance equation, but you don't know the balance equation. One of these reagents get dilute and the reaction stops after that, respectively after hour. So even though other is excess, limiting reagent forces the reaction to stop because it gets exhausted. Okay, कौन सा reagent limiting है कैसे हम निकालेंगे? Balance equation में मान लो A and B दो reagent है, उसका reaction हो रहा है. In the balance equation जो ratio है, उससे ज़्यादा है या कम है?
जो ज़्यादा है वो excess से जो कम है वो limiting.
ऐसे तरह से. Next please. I think इसके बाद आगे. Now we have only one slide. I think 3 बजे तक क्या क्लास है ना ये सारी?
हाँ 3 बजे.
Whatever. Problems I can do the problems. I'm tired. Separation of components. Now mixtures. I told you that they can be easily separated by physical means. Now if it is suspension, then the particle sizes are big. And they can, suppose you have mud water, it will be mixture. You keep it to settle. It will sediment, so the sedimentation is a process. Now, if you have a solid mixture where you can actually differentiate two types, one is magnetic and the other is non-magnetic. You remove a magnetic body and the magnetic means is non-magnetic. You can have steam. Suppose two suspensions, I will say two solid mixture, One is of bigger size particle, another is smaller size particle. So you have a sleeve. Sleeve is like a small pore size. So only those which can go inside the pores will go out. So that way you can separate it. And filtration. Filtration is also some kind of sieving. You have a filter paper which has very minute pores and through which the solvent will get out and the solution will get started. So that's how we separate the components of the heterogeneous mixture. Which now volatile components may be separated from non-volatile components simply by evaporation. Suppose you have acetone and you have some salt dissolved in it. Just you take the acetone into evaporate and the solvent will evaporate. Got it? Next case, it is very simple. Subliminal components, for example, nectarine, ammonium chloride, etc., they can be simply sublimed. You have funnel. You have a petri dish में आपने ammonium chloride रख दिया, थोड़ा सा heat भी कर सकते हो, and ऊपर में कॉर्नर ये रख दीजिए, and it will get settled over there. So that's how you can separate. Okay. Colors. Colors can be filtered. What is the physical centrifugation?
Density change when it turns at very high speed, so there are few different density rates. All centrifugal forces there will separate into different parts.
So इसका density ज़्यादा है।
वो बीच में रहता है।
ठीक है? Actually, what to say? When you go deep into this, production motion of physics, understanding of this, how this comes to play. Okay, so you rotate it. Yeah, understanding this, where, I mean, it's free, right? Free suspended in the liquid. So one chloride particle, one protein, one molecule is floating in the liquid. You are moving. Why? High speed. Why they should be going and settling into the body? So physics वाला लोग जो है वो काफी चालाक है और then they introduce a concept called pseudo force. Okay. So if you are moving your this reference frame is no longer it is no longer Newtonian. So then you have to use some kind of pseudo force, and that pseudo force here is called centrifugal force. That makes it to go and settle. So otherwise, there is no way of explaining it. It's not so simple as it looks. Okay, so they will be surrounded by centrifugation. Tensor mass settle at the bottom, lighter mass much higher. Components of dye in water. जो dye होता है, ink. Chromatography. What is chromatography?
That is separated into different speeds of going through the paper.
Right. So fiber is component, liquid के साथ is component, but they have different speed of moving along that. Say for example, we use it paper here, and crystals are purified by. Suppose you have an indoor crystal, you have made a crystal and this contains some impurity. So what you do, you dissolve it in very small amount of solvent, so it becomes saturated and then supersaturated. And then you allow to settle. The moment it settles, it will settle. ज़्यादा exceed दे दिया, तो crystal का seed दे दिया तो उसके ऊपर settle हो जाएगा. So you will get pure crystal out of it. And the impurities will remain in the solution. Invisible liquids like oil and water can be separated by using a separating fan. Again, here density plays a role. आपने एक ये हमें तो रोज करके उसको फिल किया, फिर मिला करके ये को खुल दिया. So your heavier one will go out and the lighter one will remain. And you can see it from the color and you can stop. And two miscible liquids can be separated by distillation, which are different boiling points. Water and alcohol. What is ideal? Ideal. Can you, if you are given ethyl alcohol and water, can you buy evaporation in fractional distillation? Can you make it to 100%?
Yes.
Why not?
So it's volatile. Subway stay. Subway stay. Not sure.
You can evaporate till the concentration reaches, and then the mixture boils with the same volume. So you cannot separate it. The principle of separating it is fractionation. That means they should have different boiling points, right? So only that. Then how can, but you have absolute alcohol, right? Huh? Okay, so one that. Then you use some material which can absorb selectively the water. And then suddenly that concentration is increased. And again you can fractional distillation can be used. And finally, two gases having two different boiling points, they can separate the fractional distillation. यहाँ से ऑक्सीजन नाइट्रोजन ये सब निकलता है ना कैसे करता है you cool it and then at different temperatures they will boil. So you take out one after one. Still 50 minutes are there. I have some problems.
Even there is electricity we can also separate, right? Through electricity we can also separate.
Through electricity, how? Better next page. So I think I end it here. Next day we will start periodic table. Questions please. वो जो PDF फाइल है मेरा वो that you can take. कर सकते हैं प्रॉब्लम है I have already discussed about it ना वो कुछ दिया हुआ है लेकिन उसमें सॉल्यूशन भी दिया हुआ है but I have done it already so आप अगले कर सकते हैं and if you have some problems from anywhere you can give it I have said molarity. Molarity and molar are different. Molar is number of divided by number of moles, number of so you just take molar. That's what I told her. N is a hypothetical concept, which if you are dealing with acid, it depends on the specificity of the acid. Which if you are dealing with the base, it depends on the activity of the base. If you are dealing with a salt, it represents the number of moles of salt into its charge, like that. And valency, if you are any more questions? किसी का कोई स्पेशलिटी के ऊपर कोई प्रॉब्लम है? Any question? Any question? कोई प्रॉब्लम है? कहीं भी प्रॉब्लम
Very traffic could be sort of equivalent again.
Equivalence. Yeah. Equivalent weight is defined as the weight of an element which combines with 1 gram of hydrogen, 8 grams of oxygen, okay, and then 35 grams of chlorine. So, number of equivalents is basically weight of the element divided by its equivalent weight. So that gives you the number. Okay. एक क्लोरीन एटम आपका हमारा डिफरेंस 35.5 grams as एक हाइड्रोजन एटम कितना weight है 1 gram. So 1 gram of hydrogen will react with 1 gram of chlorine to produce 1 mole of 1 molecule of HCl. So 1 gram of hydrogen reacts with 35.5 grams of chlorine. That is 1 equivalent of hydrogen will react with 1 equivalent of chlorine to produce 1 equivalent of 1 equivalent of HCl. This is a salt. This is an acid. उसका कितना निकलता है hydrogen है 1. So 1 molecular mass is equivalent mass. It is also 1 mole and another 1. So always reaction takes place in terms of the 1 gram equivalent of A will require react with 1 gram equivalent of B. So without knowing the balance equation, you can venture into this quantitative relation which is called stress problems and then anything else?
Sir, in nuclear weapons also this weight and that plays role, sir. Nuclear weapons. This uranium, this and all, we use this type of calculation to determine the blast radius.
There you need a totally different thing. Critical mass required होता है कि so that it can sustain the reaction. आपका what you are actually asking in nuclear bomb क्या होता है?
This we do this type of calculation to determine.
Any this is irrespective of any chemical reactions के लिए आपको ये चाहिए. Such is happening.
How number of valence is equal in product side and reactant side.
अभी इसको I was talking to I can very simple example. Hydrogen plus chlorine giving you HCl. Now you count 1 atom of hydrogen is how many gram equivalents of hydrogen? 1 gram equivalent of hydrogen is equivalent with how many gram equivalents of hydrogen? Obviously 1, na? So here you see 1 gram atom. Or 1 atom reacts with 1 atom of chlorine. So basically 1 equivalent of hydrogen, 1 equivalent of chlorine, this will be 1 mole of HCl. Now 1 mole of HCl is also 1 equivalent of HCl because HCl is having 1 replaceable hydrogen. So molecular mass is equal to equivalent mass. Right? So you can see the simplest example. Na? Here 1 equivalent of hydrogen is reacting with 1 equivalent of HCl to give you this. H2 plus O giving H2 इसका कितना है 2 ग्राम इसका 16 ग्राम इसका इसे छोड़ देता है तो अभी देखो 2 ग्राम रिएक्शन 60
सर वो हाफ फोटो होना चाहिए
ज्यादा दो ये 16 है ना तो 16 ग्राम और 2 ग्राम तो इसका 1 ग्राम किसके साथ चलता है 8 ग्राम के साथ so this is one equivalent and this is this is 2 equivalent and this is also 2 equivalent now let us say if it is 2 equivalent or not how will you define it as a compound so 2 into 1 like that So one mole have been produced means 2 equivalents have been produced. H2 को कैसे ये करोगे? It's just like a salt compound है. तो H का 1 है, 2 है, so basically H factor is 2. So 1 mole is equal to 2 equivalents. So 1 equivalent of hydrogen, reacts with 1 equivalent of 2 equivalents of hydrogen, reacts with 2 equivalent of oxygen to give 2 equivalents of water. ये सिंपल चीज मेरे को इतना गुस्सा हो गया था, करोड़ हो गया था. हाँ, बोलो अब क्या? Anything? पूछो, कुछ भी पूछो. तुम्हारे कोचिंग क्लास में कुछ स्टेटमेंट का इक्वेशन है देखो, कुछ कॉलम है वो भी बोलो. मैं कर देता हूँ. Now it is there. Bring up. Okay. Please.
Sir, how can an isotope of O1 be used for a goiter, sir? Treatment of goiter. Isotope of O1, how can it used to be?
Which anecdote is used? Very good. Cobalt 60. So cobalt 60 is an unstable radioactive material. So what it emits gamma rays. That gamma ray is a highly energetic ray. When it penetrates onto your body, it kills the cells. Now, tumor cell is a dead cell. So if you kill them, okay, it only takes you nutrition and grows, but it can't reproduce. Huh? So when this gamma ray strikes the tumor cell, it gets destroyed, as well as normal cells also get destroyed. But normal cells recovery is there. Yeah, tumor cells you cannot, so you get cured. Stoichiometry. Okay, a problem? Easy one. Find the molarity and polarity of a 50% solution of H2SO4. Density. इधर भाई मेरा काम कर दो.
Please don't talk.
Find the polarity of the 50% solution. Everybody try using your here. Find the polarity and molarity of a 15% solution of H2SO4. Density of H2SO4 is 1.02 gram per centimeter cube. 1.02 gram per centimeter cube. Find the molarity and molarity of a 15%, 15% solution of H2SO4. Density is given 1.02 gram per centimeter cube. Atomic mass, hydrogen equal to 1, oxygen 16, and sulfur is 30.
15% solution.
It
15%. Yeah, wait. When nothing is said, you take the same here. Wait. तो जितना छोटा लिख रहा है आप लोग तो दूर उसको खुद को दिखने को नहीं मिलता है।
टाइप नहीं किया था।
So that's why it is very important that you remember all those equations so that you can directly find out. आपको फटक से याद आए, अदरवाइज सोच के करना मुश्किल होता है।
Molarity is 270/833.
So what is that?
Your calculator.
कैलकुलेटर तो नहीं मिलेगा नहीं।
ऐसा बहुत
कितना है?
270/833.
I give you the answers. Okay. So molality is 1.8 m and molarity is
Molarity is
अरे सही है.
सही है।
हाँ सही है।
अब स्टेप्स लिखो।
सर लिखिए कैसा होता है?
स्टेप्स लिखो। ये वाला ठीक से करो और क्लैप लेके you explain them the steps na what are you doing
Yes, sir. So let's say 100 gram का हमारे पास solution है.
yes
So
मोलारिटी कितना?
molality
उसमें let's say 15 gram
क्या बोला
सर मोलारिटी कितना है आंसर?
molality का आंसर इधर लगता है दिया नहीं वो स्टेप इधर छोड़ दिया कि 98.04 volume will contain 0.153 moles so you can divide it and find it out
so इसमें 50 gram H2SO4 है. So number of moles of H2SO4 is
polarity लेंगे ना तो फिर तो
15/8
मिनट में दिया है ना
हाँ तो उसमें ग्राम में ले सकते
डेंसिटी भी दिया है so it's over you can take over just I'm just he's trying out वो पीडीएफ फाइल आप ले सकते हो पीडीएफ फाइल जो है ये पीपीटी फाइल छोड़ दीजिए पीडीएफ फाइल ये बाकी पीडीएफ फाइल आपके पास है
एक पूरी लोग के बाद क्या करेगा इसमें क्या है आप सभी करेंगे वन रो क्या
मैं तो ये
ऑन कर लो।
बंद करना पड़ेगा पहले
वहीं से
बंद करना पड़ेगा
Good evening to one and all. I would like to thank sir for this incredible lecture. He taught us the concept.
Siddharth, come in the frame of the camera.
He taught us in a very interesting way and did not make it any boring. It was a very great lecture. A round of applause for him.
Children, we will have 15 minutes break, but before we go to the break, please make sure there is a gap between two rows. I think you are able, the first day whichever arrangement